So welcome everyone to OTel Q&A, and I am super excited to have Luiz Aoqui join me. He is a developer on HashiCorp Nomad. Welcome.
Thank you. Really excited to be here. Always fun to talk OpenTelemetry. Even though I haven't used it yet, but I have dabbled a lot, and I'll share more details of my adventures with OpenTelemetry. Um, I guess I'll introduce myself first. So, as a animation, I'm Luis. I'm an engineer working at HashiCorp, specifically on the Nomad project. Uh, been working on Nomad for like 4+ years now, and at some point, I don't remember exactly when, I bumped into OpenTelemetry, distributed tracing more specifically. And it felt super interesting to me as a developer in Nomad because Nomad can be so opaque to debug, but also to like implement and deploy and use in multiple different ways. I was like, oh, it might be cool to do some distributed tracing there to get a sense of what's going on internally. Um, and then like through the course of several sort of like after our release, we usually do like an internal hack week, just to, like, cool down a little bit after that stressful moment. By the way, we just released Nomad 1.7. So if you want to try that, it's out now, which means we'll probably have a hack week soon. And maybe I'll do some extra OpenTelemetry work, but that's a tangent. And yeah, like I've tried 3 different work streams with OpenTelemetry Nomad, and I'll go into more details there. But each of them had sort of like their own challenges and also nice things, but also bad things, and then sort of I'll explain to those. Um, but yeah, that's it about me. I don't know if we should do like a quick Nomad intro because like a lot of the things since the idea of just tracing is to do the internals, exposing the internals of Nomad, I think I kind of need to explain a little
Okay,
bit
yeah,
about
that's
those.
helpful.
Okay,
Yeah, why don't you
cool.
go ahead and do that?
Cool. Let's start there. I was going to do like PowerPoint, but like Adriana told me there's more like a Q&A, and I also tend to overdo in PowerPoint. Uh,
It's really up to
so
you. If you have something, you can share it. If not, that's cool. It's super chill.
yeah, I'll just draw it live, just because, feel free to like mute, ask questions. I don't have any specific agenda here, but I'll start there and then maybe that will. But the general idea is like feel free to ask questions as I go. Don't need to wait on anything. Um, cool. So Nomad, first of all, what's Nomad? Nomad is a workload orchestrator. Think of like Kubernetes. You give it a magic file, that file becomes containers or other things running. But that's what the orchestration aspect of this is. Now, internally, it's important to understand some details of Nomad to understand what I'm going to show a bit later. Is that the general architecture is like you have 2 components, very simple, like server and client. Um, and these 2 components have different roles. So the server, and you usually have 3 or 5 servers. They maintain the quorum, basically. So they sort of are always talking to each other to maintain state. So all the jobs that you run, everything that you're running on your cluster is stored in the server. So like they have like an internal database, in the Kubernetes world, think of this like etcd, but Nomad has like its internal database. But they all have the idea is that they store the state of the cluster, and then they talk to each other to make sure that that state is replicated and sort of available in case of a failure or something like that. So maybe I'll write bullet points. So they store state. That's their main goal. The second goal is that they also do the scheduling. So the scheduling process happens inside servers. So all servers have several what we call workers. which is quite confusing because I know that in the Kubernetes world, workers is something completely different. But the workers here are the scheduler worker. And what the workers do, and each instance normally has like one per core on your machine by default, I believe. What these workers do, they're like Go routines, to go into mid. So like there's like a thread running on your servers, and their goal is to given a request to run something. So that would be like a job in Nomad Lango. Given a job, where should I place things? So imagine that I should move this. So imagine that I have, a bunch of clients here. Oh, I didn't talk about what clients do, but clients, they run stuff. So clients are the machines that are actually running your containers. They're actually running your workloads. That's the point of the clients. Uh, and normally you can have like from like 1 to like 10,000 clients. So like to infinity and beyond here. Some people really try to push Nomad to its limit. But like you can have a lot of clients on your cluster. And so the job of the scheduling is given a job or like, like a YAML spec in the Kubernetes world, given this file, how do I translate this into specific work for each client? So let's say I want to run like 3 containers here on my file. The job of the scheduler is to say, okay, like I'm going to go put 2 containers here on this client and then 1 container on this client. So that's what scheduling means. It's like, given the spec, how do I make it real? And this thing that sort of makes things real, this is called a plan. So the goal of the workers here, the scheduling workers, is to create a plan given, what we call the job spec. What's the plan? So that's what the scheduling process do. Cool. So those are the 2 main things the servers do. They store state, they do scheduling, and then the clients run stuff. When the client receives the works, like after the plan is generated, it gets validated, gets stored in state, and then the server says, okay, like this client here is going to run 2 containers. This client's going to run 1 container. So periodically, this client's going to go and ask the server, like, hey, give me which allocations I should run. And again, to translate a little bit, an allocation is like a pod in Kubernetes word. So it's like the unit of workload that's going to run. So periodically, the client goes and like, hey, what should I be running? Since we just scheduled 2 containers, the server is going to reply, hey, these are the 2 containers you should run. And then the client is going to start a few sort of internal components here. So first, it's going to create an alloc runner. And the alloc runner is responsible for setting up the allocation environment. So it's going to create folders in your file system, like folders inside that machine to store files. Is going to register service, either internally or register service in console. Is going to do things that like prepare the way of the LAN, right? Call CNI plugins, all of that happens in the alloc runner. And then just like a pod can have multiple containers, an allocation can have multiple tasks. And so the alloc runner for each task inside your allocation is going to create a thing called task runner. And this task runner, kind of like the alloc runner, is going to set up the environment for the tasks, like for the specific container. So it's going to create like environment variables. It's going to download files, download the Docker image or whatever, everything for that specific workload to run. And then the task runner is going to start. So like the end result of the task runner is like a container or a binary or whatever you want to run here. It creates like a process on the machine. So that's like how things run in Nomad. So from that file there, that you specify what you like to run, you give that to the server. the server is going to send it to the, oh, I forgot to mention the process of how it gets to the worker. So normally you have 3 or 5 servers, and one of them becomes the leader. So the leader is the only one that can actually write state to disk and write the final, like the global, the single source of truth is stored in the leader. And the leader also has a thing called the queue. So that's called the eval queue. And the eval queue is like work to be done. So like an eval is like something has to happen in my cluster. So that something gets described into an eval, goes into queue, and then the other servers sort of dequeue from there to find work to do. So the workers are dequeuing work, processing that eval, generating a plan. That plan becomes state, so like gets written into the global cluster state, and then the clients are sort of like asking for updates on that state to figure out what needs to run, what needs to be stopped, and all of that. I think that's it. That was a lot. So let me know if there are any questions on this part. Hopefully it all made sense. Cool. So let's get to the actual stuff that I did. So this is the Nomad repo. There are few. So if you search for OTel branches, you're gonna find my previous adventures putting OpenTelemetry Nomad. And I'm gonna go like sort of, and you can see like it's been a while since I've been trying to do this properly. So I'll go probably chronologically here. So the first attempt when I learned about this is like, cool, let's put distribute traces everywhere. And like my goal here was for given all of this process that happens, it's like this should all like in my mind, this is like, oh, this is like one process, right? So like this, everything here should be a single trace or like have a trace, a unique trace ID that like, oh, this could be a span. And then when it goes to the queue, that's another span. And then it gets DQ, that's another, it's like create a bunch of spans in a huge trace. So I wanted to map this process of running something in Nomad end to end. As a user, I submit a job. How do I get visibility of what's happening inside the cluster? So that's the approach that I like to call boil the ocean, because I wanted to do everything at once. So first, let's run this branch, I guess, to see how that looks like. Let's hope that the 2-year code still runs. And I was testing this yesterday, so I think it will work. I'm also going to start the OTel OpenTelemetry demo repo that I found. I was like, I need some sort of setup to run. Like I need Jaeger and I need a collector and I need an application to test. So I'm just going to start the whole demo here, just to have something to generate stuff, to generate data. So okay, deprecations or warnings are not error. So let's assume that this worked. So if you look at the branch, let's start looking at the diff. So one of the things that I did or I had to do was to have a symconfig additional configuration for Nomad. So like we have like when you start a Nomad agent, you need to pass a configuration file. So I added like configuration for OpenTelemetry endpoint, and yeah, just to like explain to like Nomad where to send all the OpenTelemetry data. And I think I have it here. Yeah, so like telemetry, OpenTelemetry endpoint, localhost 4317. That's where I'm running the the OpenTelemetry collector from the demo, and insecure because I'm not using TLS. So I think that's all I need. If you haven't used Nomad before, Nomad Agent Dev is a quick way to start. It gives you like a fully functioning cluster locally. So it starts a client, starts a server in the same process. And it's a like very handy way to try stuff. It's also ephemeral. So once it goes down, it destroys everything created, uh, which is nice for cleanup, but sometimes bad because sometimes you do want to keep stuff. So, but it's a good way to quick start with Nomad. And I'm going to read the config with the additional OpenTelemetry configuration. So let's start that. Cool. And I'm actually also going to run a job. So if you haven't seen it before, a Nomad job looks like this. It uses the HCL language, sort of like Terraform does. And there's not a whole lot to go over this right now. I think the main thing is like, and it's kind of hard to map to Kubernetes concepts. So I'll try my best. But like a group is kind of like a deployment. It tells you what to run or like how to run things. So like in the group, you can have count, like how many instances you want to run, stuff like that. The task kind of like, or like the group's kind of like the pod spec. So it tells you there's a pod spec plus deployment. So like it tells you like what to run and how to configure stuff. And then the task is like a container definition inside a pod. You tell Nomad doesn't only run containers, so you can do other stuff. And there's plugins, so there's our test drivers. And then the config is how you configure the test driver. So this is just like saying, hey, I want to run a Redis container, and it's going to expose this port and give it these resources to run. So fairly simple job here. But when I run that, it will, so like running creates, so like, as I mentioned, like it creates evals, so like the evaluation, because something changed in my cluster. So that's how I communicate changes in Nomad is like through these evals. That eval created an allocation. The allocation is like the pod. So it's like the thing that is actually running in Nomad is that. And cool, it worked. It's all running. If I go to the Nomad UI, this is a node version of the. Previously, there's like a special flag that I had to run, but let's hope it's actually running. Now, if I go to Jaeger, which is where here, I will see a lot of services. So those are for all the demo stuff, but I also see two Nomad services here. So on this boil the ocean approach, as I mentioned, like I wanted to get the whole flow end to end from user to like the clients. So I started from the CLI. So you can see here, there's a CLI, Nomad CLI, what's it called? Service with a job run action here. And then it's kind of small to see. And so like I started putting traces everywhere. I found stuff like it's one huge trace with a bunch of different spans for like each individual action that is happening. So like you can see here, the Nomad CLI ran the job run command. I think there's like, don't remember how much extra data I put. Like I was experimenting with all of this stuff. So like I put log entries here. So the Nomad CLI job run command ran, that CLI made an HTTP request. So they put request to this endpoint here. That put request became a job request in the FSM. The FSM, for those who haven't heard this term before, stands for finite state machine. That's how data replication works. Imagine you're trying to like help your friend find your house. Well, normally you tell them to go to Google, but like imagine you live in the middle of nowhere, there's no GPS. So you need to give them instructions on how to find your house, like drive 2 miles east, turn right, drive another, how many miles, turn left. Like you give specific instructions. Uh, Now imagine you're not just telling one friend, but like multiple friends, and then you you kind of give that instructions to all of them at the same time, so they can reach the same destination. So that's what the FSM does. It's like given an instruction, it mutates the state in a consistent way across all servers. Um, Hopefully that made sense. I think I confused myself, but let me know if that wasn't very clear. Um, so it creates a job request. So now we moved away from the CLI. So that's the HTTP request that was made. Now the Nomad agent is who received that HTTP request and turn it into like an internal request for a register. So that's a job register uh, command. So it calls the job register method internally. And you can see here, like I'm putting logs and stuff, trying to, events and figuring out how the OpenTelemetry library works. After we register, we have these things called emission controllers, which there are two kinds of them. They're like the mutators and the validators. So the mutators are so there are things that we need to mutate when the job comes in. So for example, we need to, for example, if you're using Vault in your job, we mutate your job to put a constraint to say, hey, only run this on clients that have Vault. Otherwise, your job will never succeed. So that's what the mutator does. It mutates the input. And there are multiple of them. So one of them kind of, I hate this word, canonicalize the input. So like sets default values that have not been specified by the user just to make sure that the job is consistent. Console connect, expose checks, and like all of these are several things that are mutating the job. And then we have validators. So they validate the job. And then it goes to reft. So like reft is the mechanism we use to propagate changes across our servers to make sure that those changes are consistent in all the servers. So it goes to ref. There's like a bunch of methods that are called there. Then it goes to enqueue. So that's the queue that I mentioned about. The eval broker queue is like, here's some piece of work that needs to be done. Now it's in the queue. And then you can see here that it got dequeued later on by another server. And what's this? Oh yeah, I don't know what this is. Yeah, and then like got dequeued by somebody to process and create that plan that I mentioned. So like, and then yeah, like there's a lot happening here, which is kind of neat, but also kind of overwhelming. But like after the CLI made the put request, it keeps monitoring the eval to get status updates. So it makes a bunch of HTTP GET requests just to get the update for that eval, and then it starts monitoring the deployment, and again start making a bunch of HTTP requests. So sort of the gist of this is like that whole end-to-end approach. Like I wanted to create a span that showed me what happens after I run Nomad job run. Because like from the user perspective, all you see is just like this output, which is quite confusing if you're not using Nomad and quite tricky to debug if you don't even know this. Like if you're an ops person and your job runs in like a pipeline somewhere, you really don't have a lot of visibility of what's happening. So that was my first attempt, is like, how do I map this process end to end and give as much detail as possible to the cluster operators. Now, why this was not a good approach is, one, because it creates a bunch of overheads. Like if you look at all the different spans, they're like 0 microseconds long or like 50 micro, like that's not very useful, I guess. Like it's nice to know about them, but like in a practical sense, it creates a lot of overhead. Like each of these have a lot of data in them that needs to go through the network, needs to be stored somewhere. So like it creates a lot of overhead for uh, every time a job runs, for example.
What happens when you just drill down into one of the spans? What kind of information does it send you?
I don't think it put a whole lot. It also depends on the span. Like sometimes they put data, sometimes like I think here I did, and where was it? TQ maybe. I put some Nomad specific data. Oh, here, like the eval ID, for example. I was like trying to experiment with adding metadata to different spans. Um, but I wasn't very consistent. So like some of them have additional data, others there's just the standard OpenTelemetry SDK data. Uh, yeah, so the first problem was the overhead. The second problem is that if you look at the diff, there's a lot of code changes. So for example, let's look at so like the HTTP handlers, OpenTelemetry does have a nice wrapper. The SDK does have a nice wrapper for like Go Net HTTP, but we don't quite use that. So like I had to manually wrap each endpoint in a function that had to use reflect to figure out which RPC should be called. So like it's kind of messy, uh, but not too bad. The actual bad part is that normally distributed tracings I think was like created with the idea of like microservice. So like there's like a network boundary more or less between your services. And since Nomad is more like a monolith, like each component of Nomad is a big monolith, a lot of these have like these boundaries are defined by function calls. And so I had to modify all the like the functions that I needed to monitor, like that I wanted to instrument, had to be modified to like take a context, for example, as a new arg to keep propagating that span forward. And so like using function as the boundary for your telemetry is not great because it just becomes like it's not as transparent as monitoring the network layer, right? So there's no way to do it automatically, and it just requires so much code change. Uh, that yeah, like after it got, and I didn't even go through the whole process. If you notice, like I stop at the DQs. Like after DQs, the span sort of ends because I just couldn't keep going with all these code changes. So like most of this PR is just adding context as the first argument to a bunch of functions, which is not bad by itself. Like a lot of functions, you know, having a context there can be helpful, especially for async work. But a lot of times it was not. It was just to keep the span going. So there's a lot of code changes for not a whole lot of not necessarily not a lot of benefit, but like a lot of code changes that were not the best changes to make. Uh, oh, hi, Matthew. Yes, I can I'll send you the list of all the branches, I guess.
Oh yeah, thanks. Also, hi. Long time no, long time no see.
Hey, nice to you. Yeah, so these are all the branches. And then like once you click on the branch, you can GitHub will give you a link for like one commit ahead, and that's the diff. Um, so yeah, so this approach, I think is very nice to have this view. And Jaeger has some nice things about giving you like how the systems interact. So like I could make this bit like each service could be like a different server, and like I'll have three servers, multiple clients, and sort of have that view. Um, but I don't think that was the right approach. Like it felt like going against the principles of distributed tracing, which is like you instrument your microservice and then the network becomes sort of your boundary of when to move the span. And I was doing it at the function level, which felt very, very fine grained to what I was doing. Uh,
Just before you move on, you mentioned that you had to like create some wrappers yourself around some of the OTel calls.
Yeah, all of these.
Yeah, so how come you had to do that? Sorry, I missed um your reasoning on that.
Oh yeah, so normally the SDK does it automatically for you if you're using a like framework like NetHTTP, or I think it does support like the Gorilla MOOCs. So normally you just import the library and sort of does the magic for you. Uh, but the way we do it in Nomad, it's like another thing to keep in mind is like Nomad is a very old project. A lot of people don't know how old Nomad is, but it's as old as Kubernetes. I think Nomad is like 1 month younger than Kubernetes. Like the V1 came out sort of like around the same time. So that was like 2017, I want to say.
Oh, damn.
Uh, yeah, so like Nomad is a very old code base. And so a lot of the things we do like predates a lot of the new sort of Go niceties. So like the whole
Oh, I see, I
HTTP
see.
layer, the whole RPC layer is something that we had to create it because there
Okay.
wasn't a way, like there wasn't a standard or like a more common way to do it.
So you can leverage the OpenTelemetry conveniences as a result because you were working with some older
Yeah, because I have so much custom code
structs.
there.
Gotcha. That's very interesting. I think especially hits on an interesting point for folks who are looking to incorporate OpenTelemetry into their existing projects. And oftentimes, like we are dealing with very old code bases, and that's not something that we discuss enough. So I'm definitely happy that you're bringing this to light because I'm sure you're not the first and only person to encounter this. So yeah, thanks.
Yeah, no worries. But like as you can see, like the wrap is very simple and does use the SDK quite a lot. But it's just like the way the project was written was not the way that usually Go HTTP handlers are written nowadays. So that was
Right.
kind of why I had to do this. Um, cool. So that was the first approach. Uh, kind of like gave up just getting too complex and the hack week was done. So I didn't have a lot more time to work on. Uh, the second approach, I sort of shift the perspective a little bit. So instead of like trying to instrument Nomad itself, the idea was to have it easier for people using OpenTelemetry and using Nomad to instrument their own applications. So what this in this branch, what I did was, so here's the task runner. So going back to the architecture of Nomad, the task runner is the thing that runs your container, that actually runs your workload. You set up the environment to run your workload. And what I did here was I started adding, so if you use OpenTelemetry before, you know this environment variable OTel resource attributes, which I think is part of the spec, and it defines, go here. So it defines um, values that are automatically added to your like span context or like whatever you create with OpenTelemetry. This environment variables sort of creates standardized values to or like metadata to add to those resources that you create. And so what I did here, oops, this one is like I say, okay, like if you're running, if you're already using OpenTelemetry and you're running stuff in Nomad, could be helpful to automatically get Nomad data for your OpenTelemetry stuff. So having the alloc ID, the alloc name, the evals, like all of this data sort of gets injected automatically for you by Nomad itself. So like there's what all of what this whole code, what it's doing is just setting the environment variable with a bunch of Nomad data. So let's take a look at how that works in practice.
And I think what you're doing here is more or less like what Kubernetes does as well now when it emits like telemetry data that you have that kind of free with purchase environment variables, right? Which is quite nice.
Yeah, like I think it got like information about the pod, information about the plans, like that's sort of just happens automatically for you when you're using the OpenTelemetry SDK and all the collector. So let's run this. I don't think I need the config because I'm not sending any data. So I'm just starting Nomad and oh yeah, I remember now. So I'm running Nomad. Nomad is going to automatically instrument my application. So I need to run something in Nomad that uses OpenTelemetry. So I found this project. I just Googled like OpenTelemetry sample job or Docker image. So I found this OTel Gen project here that it just generates traces for you. And so I'm running that image and pointing to my Docker container here that is running the collector and generating multiple traces. And this is a batch job, so it's just going to run once. So when I run that,
Sorry, what does that batch job do?
it generates OpenTelemetry data. Let me find the repo here. So yeah, so it's this project, which is very helpful. It just generates, you can tell that you generate metrics, traces, and then it just creates sample data for you in the OpenTelemetry format.
And is it supposed to be like it, as you said, it's just sample data? It's just like you're not actually using it for anything other than for test purposes kind of thing?
Yeah, it's just like imagine this is like your application that is generating traces.
Okay, got it. Cool, thanks.
And that application is running Nomad. So let's look at the data it generated. So it created 3 traces here. 3 traces, say that fast 3 times. So now, if you look at each trace, it now has all the Nomad stuff. So it has ultimate, like this was like a GitHub project, so I didn't change any source code at all. But just by the fact that it's running Nomad, Nomad itself is instrument or like populating a lot of metadata for each trace, for each span. So like it gets the alloc ID, the alloc name, the eval, the group names. Like if you are a user of Nomad and if you're already using OpenTelemetry, all the things that, like with this change, all the things that you run in Nomad with OpenTelemetry will automatically have all of this additional context and data for you. Kind of like I didn't know how much data to put, so I put like a lot. But just like the idea is to help. The idea is not instrument Nomad itself, but to help people that already instrumented their applications. When they're running Nomad, they get additional benefit. So that was different approach to OpenTelemetry Nomad. So yeah, it generates this additional context here. Now the problem with this approach was, one, I didn't know what to put, so I just put a lot of things. A lot of this is probably not useful, like job type. Who cares? And then like, because like, metadata is good, but too much metadata, it's also tricky because you increase your network packet size. You need to store this somewhere, so it kind of balloons your storage story. And so the challenge with this approach was just to, it's more like a UX problem. It's like, how do we allow people to control what information they want? Or like, do we allow them to control, or do we hard code some values? So it's like figuring that balance was a little tricky. And looking at the code, I think this is just like, I just hard code a bunch of stuff because again, this was a HashiCorp project. But yeah, it's like if you see there's no knob for users to control what kind of data they want. I think the next work is kind of similar. I was also doing this environment variable here. I haven't actually opened up here for this because like it's just like cleaning up code a little bit. This one is kind of, yeah, it's like the same as this one, but like cleaning up and writing better code with tests and everything. Uh, oh yeah, one of the problems with the other approach is that if you are already using OpenTelemetry, you're probably doing something like this. You may already be adding your own um, values here, right? So like, I don't know, you may already have your own environment variable for your attribute set there. And so like if I run this job or this version of the job now, the code that I initially wrote would kind of overwrite that. So you can see here there's no key equals value because the way I did it, I just like overwrite that environment variable and you lose stuff that you put yourself. So in this other approach, instead of overwriting, I merge the changes. So just like being nice for the user. Uh, but I think, oh yeah, I actually found a bug in the SDK here, um, which wasn't decoding the values as it was described in the spec. But then we actually figure out that there are like two versions of the spec in place. And then I had to go and change the spec. So there's like a whole side quest that I had to go through to fix this. Uh, and I think it hasn't been, let me double check. So I changed the spec, which means every SDK had to be updated. And there's the link. Yeah. And I think there's still some old ones. Like people are looking for, contributing to OpenTelemetry. This might be good first issues. They're like sort of simple. It's just changing how that variable gets decoded. And there's still some languages that have not been fixed. So if you're looking for contributions, this could be good first issues to look into. Yeah, so this is the second approach. Good for users, not so much instrumenting Nomad itself, but could be useful. Just the UX paper cuts were the major drawbacks there. Nothing OpenTelemetry specific, just how do you surface that? One thing, another downside of this approach is that since it's using environment variables, those values are rather static. Like you cannot modify an environment variable to a container that is already running. So if you want to put data that is not known ahead of time, or some data that can change throughout the life cycle of that container, this approach doesn't quite work because the environment variable is already created. So it's not great for dynamic values or things like that. So those you usually have to do inside your application. Cool. So that was the second approach. And then, each approach is like a year apart. And then after doing all of that, like I think it's sort of when I met, right after this is sort of like I met Adriana and the other folks at the OpenTelemetry community. And I start to get some guidance of like, hey, I'm trying to do this, going back to the original approach. It's not quite working because of, all of these reasons. And speaking with Adriana, and I think Ted was also very helpful in giving feedbacks on this. It's like, don't try to boil the ocean. Like you don't need to instrument everything at once. You can start small and like, find your core. I think the exact suggested like find your core business, instrument that, and then you get a lot of value out of that already. And translating that into the Nomad world, to me felt like, oh, okay, like I don't need to instrument everything end to end. We already have this eval thing that is like the unit of work. If I instrument that the flow of the eval, maybe I can get, enough information out of this to be useful. So let's see in practice how that works. So let's go to this branch now. And I don't think I need a config for this one. So let's run this version. And what this version does is like, it's going back to the first implementation, like I want to instrument Nomad itself. So this is adding traces and spans and all of that into the Nomad code itself to instrument Nomad for operators. And so going back to my traces here. Oh, nothing happened because I didn't run the job. Let's run a job to do some work in Nomad. Oh, I don't need to wait. Yeah, so now I have a service called Nomad. And if you look at the traces now, instead of, let's compare to the previous implementation. So before I had, I think it, oh yeah, I think it might have deleted. But before I had like one huge trace of everything. Now, instead of going and like trying to keep the context around each function calls, what I did was more, and you can see here, like there's a bunch of traces instead of a single one. So what I did was I didn't try to connect all those function calls, but it was more about instrumenting the specific aspects. So like here in the alloc runner, when the alloc runner starts, you create a new span. Like I didn't worry about keeping the same span going. It's like, okay, this is a new action that is happening. It's going to be a new span. And
So I guess the approach was being more mindful of like what you wanted as far as like what you wanted your traces to be. Because you went from like a mega trace to a bunch of smaller traces where like these smaller traces then have like more meaningful information to you. Is that the approach?
Yeah, exactly. It's like changing the perspective a bit instead of keeping the gigantic trace, be more like surgical about like, okay, this function is important. So this function is going to create a trace. And what this means is like I don't need to change my, my function signatures. I don't need to keep passing context around. I can just, whenever something important happens, I just create a trace there. The downside, as you can see, is that there are a lot of traces here. But a good thing, like something that I learned later on is that, well, I knew this already, but I didn't know how to use it specifically. But traces have attributes. And I think that was the key to this approach is that, and there's this notion of semantic conventions in the OpenTelemetry SDK. For those who don't know, it's a set of predefined attributes for your, just like Docker has, or I guess they're called containers, like your container engine has predefined keys that it's supposed to use. Kubernetes has its own, AWS have their own attributes or like standardized attributes that they use. And so the key to this approach was like, okay, what does that look for Nomad? And so I think it's at the bottom. Yeah. So I created like semantic convention for like, oh, what does a Nomad region key look like? Oh, it's nomad.region. What does a Nomad space key? Nomad.space. And then this allows to each span, these are all like different spans coming from all different parts of the code, but they have standardized attributes. And what this allows me to do is like I could come here and say, oh, I actually want job ID to be example. And so I can use these values to filter all this mess that Nomad is generating. It's not like a nice single filter trace. It's just a bunch of different disconnected traces. But by using the semantic conventions, I can help find and filter things better. So these are all the traces for this job here. But let's say I go to the UI now. So this job created this allocation, for example. So let me get the allocation ID here. And I said, no, I don't want the whole job. I just want this alloc here. So now it's like all the traces for that alloc. Because even though they're different traces coming from different parts of the code, different parts of Nomad, they all share the same conventions. And so that allows me as like cluster operator to go and filter out all the quote unquote noise that gets generated to be more meaningful to me. And you can see here the same things that we saw on the big trace, but now they're just breaking down. So like the alloc runner, the state stores, like the database. And I also started experimenting with like the log events as well. So instead of having, let me find the eval. I think that might be more interesting data there. So this is when I registered the job. Where did I get the ID? Oh, here. Eval ID is this. Oops, not equal. Try this again. Maybe this. Yeah. I don't remember how I did it. Let's remove all traces and then I'll find manually. I was looking for let me just get out of the zone. Sorry, the zone window got in the way. Don't see it. Yeah. Oh, maybe I'll find and share later. But the idea is that I started to experiment with logs a lot more. Maybe this one took a while. No. Yeah. Let me go back to
Are
that.
you referring to just span events or actual like OTel logs? I'm just curious.
Yeah, events. I think the data disappeared. Let me run the job again. And maybe this. No. Let me take filter out. Think of this. Yeah, so for example, this is the trace, the sort of like the scheduler part, the worker scheduler, all of that. So like I started putting logs that like as it was scheduling, so like all the scheduling decisions are like part of the trace now. So you can see like why did this change happen? And like you can see here as part of events in your span. Instead of having, the multiple tiny traces, those function calls sort of become more events instead of a new span. So yeah, that's what I was trying to find.
That's awesome. We
Yeah.
are at time, just FYI. An hour blew by really fast.
Yeah, that's what I had showed. That was the last attempt that I made.
So,
Then if you have questions, sorry, I missed chat. Do you have to add attributes each trace? Oh yeah, so the code to add the attributes, you do have to call for each trace, but you can kind of make it like helper functions to do like, let me find an example here. Yeah, so like you can pass in like helper functions, like, okay, given this allocation, this pod, give me all the attributes for that. So you do have for each trace, but you need to you can create helper functions to ease that burden.
That is so awesome. Thanks for sharing your OTel journey with us, Luis. This has been super, super helpful. I hope everyone on this call got something out of it. Um, I I think it's so important to have these kinds of conversations because I think we're moving past the, let's, intro to OTel. Like we're now getting into like more people doing really digging deep into their OTel implementations and hearing about the challenges that you've experienced and the different things that you've tried has been really awesome. So thank you so much for sharing this with us. And for those of you on the call, tell your friends who couldn't make it that we will be posting a recording of this on the OTel YouTube channel. The YouTube channel is OTel-official. So just keep an eye out. I'll post on socials and also on Slack once we have the recording up and running. So thank you everyone for joining. Really appreciate it.
Thank you, everyone. Thank you for coming, and thank you for having me.
Bye.
Thank you.